Hello, sir. Hello, I am audible.
Yes, madam, we are audible.
Okay, thank you for the confirmation. So I think we should start. So I have taken so many questions from different topics so that you will have the understanding. You can judge whether you know that concepts or not. And the TDM and all, I saw those like videos and all, but I found that very simple questions will come from that topic, and it is complex if you take this as complex. So the TDM rate optimization you asked it. So
Madam, the problem is there is exactly similar problem in one of the assignment or you shared. The calculating the bit rate, I got confused. The TDM bit rate, frame bit and spacing bit, considering that kind of stuff. Maybe you can just walk through that same example, calculating the TDM bit rate.
Okay. So at last we'll see that. I think I don't know whether Kurshid will come or not, so we can start the session. So fine. This is a question. Consider xt to be white Gaussian noise with zero mean. What its autocorrelation function is given by x. This r x tau is of the form. So what should be the answer? Gaussian noise with zero mean.
1 minute. Zero mean.
Yeah.
And by 2. Eta by 2. 1 minute. Let me, I made a note.
Nice, nice. So you know, xt convolution x1t convolution x2t is equals to minus infinity to infinity x of x1 of tau x2 of t minus tau d tau is the convolution. But if you repeat it to have correlation, x1t correlation with x2t, then minus infinity to infinity x1t x2t minus tau dt. Here x1 and x2 are Gaussian with zero mean. White Gaussian noise with zero mean. So zero mean. So yeah, it is eta by 2 delta t.
Yeah, eta 2 delta t time domain. Yes.
Yeah.
Eta by 2 is frequency domain.
Eta by 2 in frequency domain, because here it will be 1. So this type of question can be directly asked, but you have to remember this the difference between convolution and correlation. And sir, can you tell me the difference, like where it is used? Convolution, you know, for linear system. Why the correlation is used?
Correlation is used to find the power.
Yeah, it is calculating the power, because here the autocorrelation of x tau is nothing but Fourier transform is power spectral density (PSD). But in practice, this is used to find the similarity between two signals.
Yes, similarity between two signals, and the self-similarity becomes a PSD.
PSD, yeah. So, I think that's fine. So, the next question. This is 1-1. So, next question is, consider the probability density function of the message sample m given as fm, this one. What is the optimal quantization level corresponding to the 0 to 1?
Okay, 1 minute. Optimal quantization. I think Lloyd's is the one which is optimal.
Yeah.
And there is a formula for that. That is integral integral 0 to 1 fn n multiplied by n dm by divided by integral 0 to 1 fn n dm.
Yes. Not yeah. So you can expect this type of question only from that our quantizer. So if you are having this, so optimal quantization level is given by integration of m fm dm. Here integral is 0 to 1. So if you calculate this 0 to 1 m 2m 1 minus m dm, 0 to 1 2, we can take out m square dm. So 2m square by 2 minus n cube by 2 cube by 3, 0 to 1 2 1 by 2 minus 1 by 3, so 2 6 1 by 3. Answer is 1 by 3. So here you can have different probability density function, but similar answer you can expect.
So
Similar
the
question.
denominator is always 1, no? That, as you said.
Yeah. Denominator is always 1, yes.
So
Because it
that
is a probability density function.
that we need not compute. So blindly we have to just compute the integral
Ha.
of the numerator only.
Yes. Because this probability density function f PDF is equals to always 1. And integration of all probabilities for all the event occurring is always 1. And here, first of all, they can't give an example where they are just considering only few part of the probability density function, because here it is not applicable, and it is not so in generally IIT frame that question which is actually real also. So this can be possible, the message example so that's fine.
But I wonder then why the formula itself gave that
Yeah, so
integration.
I told you this one now, this thing, that if the probability density function is defined for these long periods, but only the given thing is to you is this up to this interval. But here, if they are not giving only up to this interval, if they are giving up to 0 to 1, so they are defining also only up to 0 to 1. So there may be cases where they are not defining up to other for other values of x, the time axis.
Okay.
Yeah, so for that case, we required to have. And the third question is, sorry, second only. So what is let this is also very good question, and this kind of question we can expect. So let the x1, x2 to xl be independently identically distributed Gaussian random variables with zero mean and variance power each. What is the variance of this one? And similar question can arise, what is the mean of this one?
Okay. This is interesting.
Yeah.
So the variance is not a linear formula. Just a minute.
Hmm.
Variance formula. Variance of function.
Yes. So first of all, we know that if two x1 and x2 are independent, then E of x1 x2 is equals to simply the multiplication of E of x1 x2. Okay. And in fact, if we take this independent, then mu, the mean of all random variables, is simply the sum of mean of individual random variables. It will be mu is equals to mu1 plus mu2 up to mu n, only if they are independent. And if we calculate the variance, how the variance is defined, x minus mu square. Okay. So suppose x is x1 plus x2. Now E x1 plus x2 minus mu square. So if E x1 square plus, sorry, this one we can take x1 plus x2 square plus mu square minus 2 x1 plus x2 E of x1 square plus x2 square plus 2 x1 x2 plus mu square minus 2 x1 minus 2 x2 E of x1 square plus E of x2 square
Made a mistake. I think x1 square in the above x1 plus x2 square plus mu square minus 2 mu into x1 plus.
Yeah, that's why 2 mu x1 is 2 x1 2 mu x2. Okay, so 2 E x1 x2 plus E of mu square minus 2 E of mu x1 minus 2 E of mu x2. So at the end, what I'll say, what you'll find is after solving, we'll have sigma 1 square plus sigma 2 square. So this is the formula for independent. We can in fact solve here also. So E of x1 square is what? Mean square value. E of x1 square is nothing but mu square, because E of x1 you can write and x2 you can write. Sorry, x1. No. This is what zero mean. It is given as zero mean. Okay, zero mean. Then it is sigma 1 square and sigma 2 square, and here what it will be? Yeah, zero mean is given, so it will be easily solved. So all the mu term will be cancelling. Here also, this is E of x1 x2 from the independent property, so it is also cancelling. So it's simply just multiplication, sum of 2 square. So how you will calculate this? So let's calculate for this one. So sigma 1 square plus 2 sigma 2 square, and sigma is same actually, it is 4 variance. So you can see 4 plus 2 into 4 plus 3 into 1 second. So you can see from this part, 3 into 4 plus 10 into 4. So this will be variance of expressions क्या था, x1 plus 2x2 plus 3x3 up to 10x up to 10x10, where x1 x2 up to x10 are independent random variables, and you have asked what is the variance of this one. So we found that if x1 and x2 are independent random variables with zero mean, then this variance of that sum of those two random variables is simply the sum of the variance of individual random variable. So you will have sigma square of this one. You require to find this. So sigma square. So here 4 plus 4 plus 4. So we will take 4 out. 1 plus 2 plus 3 up to 10. No. Here what is happening? So we require to square this, right? So whatever variable will come along with this, suppose A is there, B is there, so all this will become square. So A square should be there. So A square, B square. So yeah. So 1 square plus 1, 4, 9 square and 100. So you have to calculate. Calculate what is the value. There is one formula.
Yes, geometric.
Yes. 1 plus. No, geometric formula will not be here, because this ratio is not same. How will we calculate? This is 1 plus 4 plus 9.
1 plus 2 square plus 2 square plus 4 square.
Yeah, we have one formula. I don't remember that.
Yes.
Okay, so whatever value we'll get, it will be matching to this one. So what is the funda here? This type of question you can definitely expect in your exam. So
yes, to summarize that identically distributed with mean is 0 and common variance is mu, then it is not exactly linear, right?
Yeah.
So we have to square. Suppose a1x, for example, sigma square of ax is nothing but a square and sigma square x.
Yes. So sigma square of the form a1x plus b x2 plus C x3
is equal to
suppose D or n xn. So is equals to
yes.
A square sigma 1 square plus B square sigma 2 square so on n square sigma n square. So this is very important for in general we then generally consider independent
And
zero mean also zero mean and same variance. So if the same variance is there, then the A square plus B square plus n square should be there, then definitely it will be. So
I got it.
yeah, okay, thank you. So next question is consider xt to be white Gaussian noise with zero mean. Yeah, this is also similar. It's power spectral densities of the form. Yeah, so you were asking about the same, right?
Yes. Power spectral density is nothing but the autocorrelation in frequency
It will
domain.
be eta by 2, right, ma'am?
Yes, yes,
Power
yeah,
okay.
yeah. So what if you are asked to calculate autocorrelation of this one, xt?
Autocorrelation is eta by 2 into delta tau.
Yeah, so remember this, that there is very high chance for mistake here.
Frequency domain it becomes delta tau. Okay, eta by 2. That's it.
Yes, yes. In frequency domain, this term becomes eta by 2 only. But if you have asked to calculate this, sorry, first question with autocorrelation function, then only eta by 2 delta tau. And remember this one is in the form of tau.
Tau is the delay.
Yeah, yeah. So moving ahead, yeah, this question is similar to last questions. So I want that if any question come in between, you solve. Should solve this question. The levels of 4 array PAM constellation is given
Okay,
as
ma'am.
S is equals to, yeah. Okay. So here the twist is the probability that none of the x1 x2 belong to the set this one.
So I have a mental mnemonic. If something like that is given, probability that none of you invert it. 1 minus probability of anyone, or probability of everyone.
Yes, yes, yes.
No,
Probably just invert it.
Invert means what? It becomes
No. So here it is asking the probability that none of this belongs. So you can actually calculate
the
P of
probability of x1 or x2 belong.
x1 x2.
Ma'am, 3 by 5, I'm getting 3 by 5 D.
355. I think our answer is different.
Okay, ma'am.
Answer is
Okay, got it, ma'am. Got it, ma'am. It will be. I got it, ma'am. 3 by 5 square. It will be 9 by 25.
So how you deal with this one? X1 x2 belongs to none of the x1 x2 belongs to this one.
First of all, ma'am, I calculated all the probabilities. Then, for this not belonging to this given set, minus alpha 3 alpha 1 minus 4 by 15 plus 2 by 15. That is what are the chances of them having, and I subtracted it from 1. So I will get that, and this does not belong to given set. Now there are two random, and these are two variables taken independently. So I am simply multiplying the two incident.
Yes,
So
yes. So what is happening, sir? Here we have calculated this probability of P of minus alpha and P of 3 alpha using this property of summation of all the probability I is equals to 1 in the sample space. Now what is happening? These symbols are x1 and x2 are independent. So for x1 we will calculate 1 minus p of minus alpha minus p of 3 alpha. Similarly for x2 we will calculate p of minus alpha and p of minus 3 alpha, so that x1 does not belong to alpha and 3 alpha, and x2 doesn't belong to alpha and 3 alpha. Now since these are independent, these will be multiplied together. So it will simply the answer will be this 1 minus p of minus alpha minus p of 3 alpha square. You have to calculate p of minus alpha and p of 3 alpha using the conditions which are given here. Sometimes this type of question gets looks like very confusing to us. So you please make sure that you don't make any mistake in this. So did you get it?
Yeah, I understand, madam.
Okay, thank you.
But yeah, I understand in a slow mode because my brain is slow. Because this is one exam I failed twice. I know if we can conquer this, your brain is very sharp. Probability theory. I understand, but of all the mathematics subjects, calculus and linear algebra, I find probability is a very, very brain twisting. We have to, because there's a.
Yeah, we have to bear that pain of mathematics going in probability. It's very tough. If you go to random variable and all, this will become again tough. So basically in the 4 PAM constellation or 5 PAM or 8 PAM, so here there will be some symbols, and that symbols can act as a random variable, and that random variable will have some values associated with it. Suppose it is mapping to alpha, it is mapping to minus alpha and all. So at that time, if x1, if the samples are given as independent, they are simply getting multiplied if they are asking probability at together at once. So you have to make sure. So I think it's clear. So here that twist was actually good, so I took this question, and this is very normal question, but yeah, we usually make mistake here. So the question is, a real wide sense stationary random process xt must satisfy.
Then I think C option.
C, correct. C.
Why above first twos are not correct?
Ma'am, energy will vary, but energy will not be constant, but this energy of the correlation, it will depend on the shift only, I think.
No, answer is D. All of those is correct.
Oh.
Here the mean is constant. Here the RMS is constant, and here it is, as you know, this. So what is happening in wide sensationary? So have you taken any example with wide sensationary? Like why we call this wide sensationary? Like sir taught you in the class. So can you tell me a little bit about it?
Basically, it means the delayed signal is constant delay of tau at any time.
Anyhow, these are the properties of wide sense stationary random process. But first of all, let's see what is process. So what happens when a random variable, random variable is just a mapping of the outcome of any random event to a real line axis. For example, x of h, we are mapping it to 1. X of t, we are mapping it to 0. So in similar way. So that if that mapping becomes a function of another variable, suppose here the time, then it is called process, random process, because it's just a over of the random variable. So what happens? This wide sense stationary random variable means here it is stationary at the mu value, mean, and at the RMS value.
Excuse me, ma'am.
Yeah,
Ma'am,
yeah, yeah.
why we call it wide sense?
Yeah, there is a reason behind it. Wide sense because this is covering up to large, very large time interval. Let's see first this one. Like can you tell me the this relation was there na? Mean square value is equals to mean value. What was that? Mean square value. So mean values
Yes,
minus.
ma'am. Mean
Yeah, yeah.
sigma square equal to.
Mean square value is equals to mean value. So something was there. I don't remember that
It's
particularly.
x square t is nothing but variance, right? No?
Yeah,
Yes,
yeah,
ma'am.
yeah.
E of x square equal to. One second, ma'am.
Yeah, yeah. I also don't remember. Mean square
There
value.
was this curve on the RHS minus mu square. I remember that.
Mean square value minus mean value ka whole square. I remember. Yeah, yeah. That's why. But
Okay.
I don't remember this one. Uh,
One second, ma'am. Ma'am, I think we should Google it. That will be.
yeah, we can Google it.
Yes, ma'am. Sigma square equal to E of x square minus mu square.
So yeah, yeah. So this is
Variance
ha
is
ha
equal
ha.
to
Mean square
mu
value
of x square
e of x
minus mu
square
का पूरा
minus
square.
yeah
Mean
e
mean पूरा square. Yes, ma'am.
yes, yes. So this is the relation between these things. So what is happening in white and stationary? This is becoming constant. This is also becoming constant. So this the variance will have a longer value. Somewhat was like I don't remember why it is called white sense, but yeah, it can sense up to longer values of variance. Suppose this e of x minus mu square is equals to 0. So there will be various values of x, x1, x2 up to xn where this expectation values become 0. So here the criteria is this. But yeah, you please remember this thing. The mean is constant, mean value is constant, and this thing it depends on the only shift. This type of question only you can expect from Y sensation in not much. So moving ahead. Yeah, this is also a very good question. Hmm. Consider a random variable theta uniform in this one. Probability density function of the random variable phi is equals to sine theta. Calculate this. It is a question from transformation of random variable.
Ma'am, I looked for it in Chat GPT.
Uh-huh.
This wide sense. So it is saying that wide sense and this strict sense they are two stationary process. In case of wide sense, the autocorrelation is not a function of time, and in case of a strict sense stationary process, it has constant PDF over time. Its PDF is constant over time probability distribution function. So that fact is its correlation is constant, does not depends on time, only depends on the time interval tau. This is why it is called wide sense.
This
It
one. Hmm?
Yes, ma'am. This term wide sense refers to the fact that the autocorrelation function of this process is only dependent on the time difference between the 2 points being compared rather than the absolute time value themselves.
Okay, okay, okay. Fine, fine, fine. Sometimes ChatGPT also gives a random answer.
Yes, ma'am. Actually, I used it for some technical multiple choice questions also, and for this UPSC civil service preliminary question also. It is every time giving wrong answers. if we somehow point it to some data, it is correcting itself actually after that.
Ha ha ha.
Yes,
No,
ma'am.
if you say that you are wrong, wrong,
Yes,
wrong,
sir.
then he'll just sorry, I apologize. Huh.
And I was actually looking for something related to power system analysis in question. So it took actually 5 minutes to start that giving answer only. It took 5 minutes. It was just thinking what to write, what to write, what to write. So I closed it last night.
Yeah, yeah. So this happens. So we cannot blindly trust.
Yes, ma'am.
But it's okay. Yeah, I remember this strict sense and white sense. So there is difference
Yes,
between.
ma'am.
So it can be possible. So this question.
Actually, I don't remember it now, ma'am. I
Okay.
will have to revise this thing. So
Mm. Sir, you have any idea how we will calculate this?
I have read about it. This is PDF of function of a random variable, right?
Yes, yes.
So there is a general formula for that. PDF of a function. Wait a minute. I'll read the. Yeah.
ma'am, it is uniform means it will be constant at
Yes,
this
yes.
interval 0
I'll
to pi
give
by.
you a hint. Yeah. Here
Yes.
Okay.
it will be 0 to pi by 2. So 0 to
Mm-hmm.
pi by 2 means 1, 2 by pi here.
Mm-hmm. Yes, ma'am. So it will be 2
So
by.
what is happening here? You are having the function of random variable.
So there is a formula given, madam, that is f of x divided by dy by dx at substitute x is equal to inverse of y.
Yeah.
Okay.
Something
So,
like that. Yes,
uh,
yes, that is the formula.
so here you have to calculate like this only. So, but yeah, you should know that this topic is coming from transformation of random variable.
Okay, ma'am.
Uh, so this is very important for your interview also. So yeah, so if we calculate this f of x, which is f of x is nothing but f of theta, what we have. So it is 2 by pi, and this d. You remember? Before looking at your copies, did you remember this formula? Because this question you can expect. This type of question you can expect, like it's a tough type of question. But yeah, it will come. Theta sine theta, and here this 2 by pi cos theta, and here it is inverse. So what is inverse of cos theta?
And
Two.
sec theta.
No, no, no. This inverse.
Oh, this one, ma'am. One
Uh,
second.
I think it one.
Cos inverse theta root under.
Yeah, yeah.
It's
This. Hmm.
got it, ma'am. One second.
Sine inverse phi.
Here. It is 1 minus pi square. Yeah. Phi ranges from 0 to 1 because of this. So answer is, I think, C. I have to check. Answer for question number 4. Yeah, answer is C. So this one is the inverse of this. So you can expect this type of question. You remember, please, this formula. It is only formula based. So nothing to worry about. This one also. So sometimes we don't know the formulation of mean square value and all. So what is the formulation of mean?
Ma'am, B, option B.
What option B you're saying? Sir, you?
X times probability distribution function integrated from minus infinity to plus infinity.
Yes, you are right. So this is, so what is the formulation for mean square value? E of x square, E of
E
x
of x
minus mu
square.
square. These two,
Hmm.
tell me.
Okay, ma'am. Ma'am, give me 2 minutes.
Yes.
it will be x e of x square will be x square times PDF integrated over whole interval minus infinity plus
Yes,
infinity.
yes. So what I'm telling you, so whatever function will come here, it can be any function. So x minus mu square, only the difference will
Got it,
come
ma'am.
here. Okay. And what if you are asked to calculate in time, in discrete time? So it will be simply xi pi, I ranges from 0 to n minus 1 or minus infinity to infinity. So the sum of all probability multiplied by their own magnitude, the random variable samples multiplied by their samples. So it can be asked in n array PSK or m array PSK. So fine. Moving ahead. Question number this one. Given the here the so given the probability density function, this one, the variance is defined. How will you calculate variance?
D.
Yes, yes. So the answer is D. Now this question. Consider xt to be wide Gaussian noise with zero mean and autocorrelation function. This one. It is passed through an LTI system whose impulse response is this one. What is the power of the output random process? YT. So there is one formula. If this is HT, this is XT. So I don't know, like it's very difficult to remember all those formulas of the course. But yeah, you please remember this formula. So if you convert this into X of F, this is H of F, this is Y of F. Then S of Y of F is square X of F. So this is the formula.
Okay, ma'am.
So it's
Ma'am, please show
sorry.
the question.
X X X F. So what I'm saying, yeah, what I'm saying, the power spectral density after passing to LTI system is just a multiplication of the square of the transfer function multiplied by the input power spectral density. Now you can easily calculate.
Yes, so we have to compute Fourier transform.
Yes. So what is HF here? Tell me, what is HF? We will calculate. Let's convert this into here area is
No,
what?
no, it becomes a rectangular in Fourier.
Rectangular from minus 2 to plus 2,
Hmm.
and magnitude will be 1 by 4 times.
Yes.
So 1 by 16 into 2. Ma'am, answer will be 1 by 16.
So yeah, we will calculate 1 by 16 into excess of f is 2. 1 by 8.
There is option with 1 by 8. There is no option, ma'am.
Wait. So what is asking? Power. So how will you calculate this
Okay,
power?
okay.
The power spectral density you are given. The power is nothing but this one, na? Autocorrelation function 0 value tau. This this is power, right? Mean square value is power. So I think you have to take the integration of this. Yeah. So how will
Minus
So how will you
minus 2 to plus 2.
yes. So it is y of
Minus 2 to
f
plus 2, there
e
will be
power
4 by
j 2 pi f tau.
1 by 2, ma'am.
But here it will be 0. So simply integration of s y by f df. And here you have delta tau also, na? So it's in what
No,
is the
ma'am, there will
range?
not. Ma'am,
No,
there will be delta tau in the frequency domain.
no.
Okay, in the time domain. Okay, ma'am, tau domain.
Yeah, tau domain. But here you
Okay.
will have Rx tau. So what is the answer?
Ma'am, I think now 1 by 2 will be the answer. C.
Uh, so 1 by 8 into
1 by 8 integrating it from minus 2 to plus 2 because of this filter.
Yeah, yes, 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 yes. Minus 2 to 2. So simply minus 2 to 2, it will be 4 into 1 by 8, 1 by 2. 1 by 2 answer is there, na? Yeah, answer is 1 by 2.
Yes, ma'am.
So here this type of question can come. So you please remember what is a processor. First of all, you know this thing. Then you have to know the basic calculus. And you have to know this Rx tau also. At T, tau is equals to 0 is just the integration of power spectral density. It is a inverse Fourier transform.
No, madam. Why we have to calculate the integral directly in Fourier
No. See, what is the question is asking, what is the power of the output of the random process yt? We know that this
So
this
that
rxx, suppose this one ryy tau Fourier transform is x y
tau
f. Okay,
that we calculated already 1/8.
this is power spectral density. It is 1 by 8, but
Okay.
the power of a signal is defined by RY0. You know this?
Power is integration of this power spectral density across whole frequency domain, and it is limited to -2 to +2 because of this filter. Right,
Yeah.
ma'am?
It is defined because it is nothing but it is giving RY of 0. It is giving, why it is giving RY by 0? You remember this? If you calculate the inverse Fourier transform, this is the formula of the inverse Fourier transform. But if tau is equals to 0, then it will be 1. And simply the this one minus 2 to 2, because filter is from minus 2 to 2. And this is definition for power.
No, wait a minute. 1 by
Yes.
Yeah. Yeah. HF is 1/4. See, I'm thinking that we can calculate. We know SYY, we know H of F. I thought we can calculate X of F.
No. The
No.
power is defined. Defined like this, and so we have to calculate using that formula only. Like it is
R, yeah, RXX now.
yeah. It's nothing but this one.
Okay. Okay.
Yeah, this question is good. So this can come in your difficult question part. Okay. So
So answer is 1/2, right?
yeah, answer is 1 by 2. So moving ahead, this probability density function of a Gaussian random variable. This is very sure, but yeah, we do make mistake in this. So what is the answer?
C, ma'am. C.
Yes. So this is C, and it is very simple. Now this easy question again. Consider the random variable x with the probability density function PD of this one. The value of the constant. How will you calculate this one? If any value is there.
No, integration will be equal to 1 across whole.
Yeah. So you just integrate with respect to x. Dx was equals to 1. And then k power minus lambda x dx equals to 1. Whatever value you will get for k, you just feed it. I think answer, I'll just look it at answer.
So the range is 0 to infinity.
1 by lambda, ma'am. 1 by lambda.
1 by lambda. I have to check it once again. The answer is lambda, I think.
Yeah, got it, ma'am. It is lambda. Lambda.
So the answer is lambda. Here we'll just go through the answer also. Here we know the answer. Okay. So yeah, moving ahead. Yeah, this one also. When the random process xt is Gaussian, tell me.
And C.
Yeah, this type of theory question do like it will definitely come. You can expect up to 5 to 10 questions you can expect. So the random process xt is Gaussian only if and only if the joint probability density function of this one for any and n is Gaussian. The autocorrelation of the random process Gaussian is not always correct. The probability density function xt for any time t is Gaussian. It is also not correct. But the joint probability density function should be. And the power spectral density or sensitivity of the random process is flat over. This is for the, I think, white sensationary. Okay. Yeah, this is the case. So the random variable formed by linear combination of Gaussian random variable is
Gaussian.
Gaussian.
yes. Nice. So this eighth question. Yeah, you know this how we'll calculate this. I think it's very. Wait a second. Yeah. How to calculate this one?
Ma'am, Bayes theorem. We will use that Bayes theorem.
Yes, yes. So the basic funda is whenever the conditional probability comes, so you just try to focus on the Bayes theorem only. So the thing is, if it is asking P of A1 by B naught, then P of A1 intersection B naught divided by P of B naught. You know this, right? And how will you calculate P of B naught? P of B naught will be calculated from the Bayes theorem. From Bayes theorem. And just summation of P of B naught AI. Can you calculate quickly? Like we will just mark it.
Okay, ma'am.
Yeah. P of AI. Check what is the answer.
Madam, we can
Yeah.
also write the numerator as P of A given B multiplied by P of B,
Yeah,
right?
yeah, yeah. No. P of
A given B.
no. P of B1 given B not given A1 into P of
Multiplied.
A1.
Yeah, yeah.
Hmm. So this type of question you can definitely expect.
Ma'am, actually, I am not getting. I don't know why.
Uh, so
But this is.
after in your free time, do calculate this question. Please do visit the lecture again to have some understanding. Do not after when
Ma'am,
you
please write down that formula here. That
okay.
formula
So let's solve only P of A1 B naught.
A1 given that B naught has happened. B naught given that A1 has happened into. I'm
F
actually
of
putting the right values. I don't know.
P of A1 P of A1 plus P of A0 P of
Into
A0. So
A
let's
naught.
calculate itself. What is the value of P of B naught A1? P of B naught given A1. Here it should be B naught first of all. No. This we have to calculate periodic a posteriori.
No, it is better to make the sketch, madam. There is a diagram. The left side is sender, right
Yes,
side
ma'am.
is receiver.
Yes, ma'am.
Okay. So yeah. So yeah, the question we are having is P of A1 by B naught. Okay, this is we are having. Now P of A1 by B naught, how you can write it? First of all, P of A1 intersection B naught divided by P of B naught. You know this from conditional probability theorem. Now P of A1 intersection B naught, we have to check from the given equations. So from given equation we have found P of B naught. P of B naught by A1 into P of A1 divided by P of B naught is what? P of B naught divided by A naught, P of A naught plus P of B naught A1, P of A1. This is what? From the base theorem. Okay. Now we have to put it. P of A1 is what? P of A1. P of A1. Okay. First of one thing we can do.
There is something wrong with this question, I think. Here you have corrected it also.
So P of
Yes.
A1 is 0.75. So P of A2 binary is okay. We have to first read the question also. Na? It is a binary symmetric channel. So P of A0 is simply was 1 minus 0.7. It is 0.5. It is what is 0.25. Okay. I was thinking why it is not given for P of A0, but it is binary symmetric channel. So it will be sum of only two channels. Now this 0.8 and what is given 0.8. Okay. Yeah. So I don't remember this binary symmetric channel. We have to first draw this binary symmetric channel. This is x1, a0 and a0 a1. Let's see, a0 a1. Let's draw with different color. This is a0. This is a1. This is a0. This is a1. So this is a case with binary symmetric channel. We have two binary symbols at the transmitter and two binary symbols at the receiver. And what they are saying the cross probability, I think, cross B0 A0 and B1 A1. No. B0 A0 is 0.8. It corresponds to transmitter received. So received events it's B0, sorry. B0, B1. And here it is 0.8. So what it will here it will be 0.2.
I'm getting 3 by 4 now.
Yeah. So answer is 3 by 4. Let me check. Answer is 3 by 7. So so this is the probability for B0 A0. Now we have all the values. We have to just put the values and get it. So what is the probability for B0 A0 A1? It's 0.2 multiplication of 0.75 because point of A1 0.75. Now it is 0.8 multiplication of point of
Ma'am,
A1.
can we go back to the question for 1 second, ma'am?
Yeah.
Okay, this is probably B0 A0 given and B1 A1 is given. Okay, ma'am, and we have to find B1 A. Okay, ma'am, got it.
So this is the case with binary symmetric channel. Now this is B0 A0. This is 0.2. P of A1 is 0.75. You just calculate this. We will definitely get the answer. Or else I have to calculate.
Yes, ma'am. I'm now getting 3 by 7.
Yeah. So you'll definitely get 3 by 7. So this is a case with binary symmetric channel. We have to first understand the question, then only we can jump. But I was thinking that why other values are not given, because it is understood from the binary symmetric channel. So okay, we should move ahead. Sir, is it clear?
Yes, madam.
Okay. So fine. Let's go to the next question. So again, similar question is there or same question? No, I have not taken same. This is with different values. So similar question is there. We can calculate for the similar way, and I have to check what is the answer. It is.
Ma'am, it is same question, repeated question.
0, 1. Okay. Repeated question. So answer same. Okay. So this is very normal question. Tell me what is the answer.
C, ma'am. Just now you told me.
C. And now this is the question with the the autocorrelation
B,
of the
ma'am. Option B.
B. So what is there?
Same thing, ma'am, in the tau domain.
Yeah, yeah, same thing in the term domain. Consider a wide sense stationary WSS random process with autocorrelation as an input and output. So yeah, this is the output of LTI system.
How can, madam? Two times correlation. One.
Yeah, because s- this autocorrelation function Fourier transform is um what is power spectral density.
Yes.
Power spectral density. Let's calculate this. I was also thinking the same. H of t x. So uh,
Oh, okay, okay, okay.
how,
Okay, okay.
how it is?
Yeah, because the autocorrelation itself is a convolution between itself. RX. No, 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 no,
Autocorrelation.
no, no.
No, but it is given in the lecture. It seems. Answer is B only. Question: have you have calculated?
Uh, Ma'am, actually, we will find the autocorrelation of the output, and there we will put the value of input, and input value will be in the term of convolution. So, with some variables interchange, we are getting the answer. I don't remember all
I also
exactly.
don't remember the processor, but you can refer the lecture. But you please remember this.
We will start from the expression of the output. We will find the autocorrelation of the output, and in that expression inside we will put the xt convolution and ht convolution, so we will get this value.
Okay, okay. Yeah.
And
So
there is
yeah,
actually ma'am, there are some mind boggling number of interchange that sir did in the lecture, so that is ridiculous actually. I will
so,
not remember all
so
of
for
it.
your exam, you can just remember some of those things. Like you can definitely remember so that you don't have any issue. Because otherwise, it's very difficult to derive everything at the end in the exam. So these are the repeated questions, so you can expect this type of question. This theoretical question will be definitely repeated. So you can expect. And similar question, this repeated question. I don't know why it is repeated. And then yeah, this question. This will again from the concept of transformation of random variable.
PDF of the random variable y is how much? Okay, okay.
So that formula was there, na? F of x d by x of f of x inverse. So you have to solve this. I'll tell the answer.
Okay,
You
ma'am.
solve. Yeah, but
Okay, ma'am.
this the transformation of random variable will definitely have one two questions, which makes it difficult to have to solve in the exam. So you please practice before it, so that you don't have any issue with that. Yeah. So this is a good question. I think this is last. Yeah. So this is very good question. Uh, tell me what is the answer. You know, out power. So power is nothing but YYF of this filter 0 to infinity. So you have to calculate this. YY of F is nothing but XS of F mod of H of square.
H
So
of x square.
huh. So this one x of F is eta by 2. H of F
It will be delta f plus 1 by 2.
delta F plus 1 by no.
Okay, we will have to calculate it then, ma'am.
Yes, yes, yes. You have to calculate it. So I don't know what is the formulation for this, but yeah, you have to calculate this. That
1 by j omega plus 1 by 2, I think. Yes, ma'am. Something like that. Plus or minus, I'm not sure, but 1 by j omega plus.
uh, 1 by j omega
Yes, ma'am.
plus. Yeah, 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 yeah.
Actually,
A
this is,
plus j
yes,
omega,
ma'am.
right?
So 1 by omega square plus 1 by 4 into eta by 2, and then we will integrate it from minus infinity to plus infinity, right?
Yeah, 0 to infinity. Then you'll have the answer. What is the
Ma'am,
power
it
of
will be
the?
very complex. It will be very complex actually.
Yeah, it will be running a complex, and answer is this one, eta by 2.
Ma'am, please solve it here.
Okay, okay, I'll solve.
Just
So
this one, ma'am.
h of f, h of f is 1 by 2 plus j omega. So what is mod of h of f? It is
1
1
up
by
by
4.
root omega square root under.
Yeah, it will be root under. So I am just thinking that mod of hf square will not have this 1 by 4 plus square
Mm-hmm.
eta by 2. Now one thing I'm wondering, uh, h of f. Okay, let's solve. 1 by 1 plus 1 by 4 plus omega square d. No. This should be up to d tau, right? Differentiation should be in d tau.
1 second, ma'am. Consider 0 mu by percent PSP give eta by 2 delta 2. Ma'am, if we will convolute it in the time domain, PSB eta by 2 delta tau.
No, this power spectral density is a function of f, right?
Yes, ma'am.
So convolution with respect to mod of SF df. Or else we can calculate. Okay, let's solve this only. Let's get some answer. But I'm not sure. Okay, here it should be f or tau. If it is f, 2 pi.
Ma'am, first we should calculate the power spectral density of output, which will be this multiplied by eta by 2.
Yeah, eta by 2 will be simply
And
here
then
eta by 2.
we will actually integrate it from minus infinity to plus infinity.
Yes. Because here omega ranges from minus infinity to plus infinity. So 2 pi
Or
f
2
square.
times 0 to infinity also we can go. 2 times 0 to infinity if it is
Yeah.
symmetric.
So this thing we have to do eta by 2, and answer given is eta by 2. So this means this is giving you 1.
Omega plus 1 by 2 whole square. And it should be actually sinusoidal now, ma'am.
No,
It
it is
is
tan square formulation, x square plus a square. Tan x.
1 upon. And tan infinity will be pi by 2. Okay. Ma'am,
Yeah.
what is the exact formula? I don't remember this formula. Tan inverse x by a.
Tan inverse x by a is this one. 1 by x square plus a square.
There is some a term outside
1 by
also, I
a,
think.
I guess. Or
Okay, ma'am.
a. Okay, fine. Somewhat here is the formulation of this. So, tan inverse, if it is x
So
by
there
a.
should be some term of pi. There should be some term of pi then, ma'am.
Yeah. Or else we can integrate with respect to omega. But if we integrate with respect to omega, 2 pi f.
Ma'am, please show the question. I will save it's a screenshot. I will try it later on.
Yeah.
Okay, 1 second. Okay, ma'am, done.
Okay, so you please solve this. Time is also up, but I'll just if I solve it and get it, then I'll just mail it, uh, or else I attach this in the PDF form so that you can look at it. So I
Okay,
think
ma'am.
I have taken good questions. So please go through it once again so that you won't have any difficulty in that. If
Got
you
it,
have
ma'am.
any further question, just let me know. So I think this is fine for this course. And next semester I'll take most probably this applied linear algebra for machine learning and all. Aditya K Jagannatham sir course only. So you can look at it that.
Okay, ma'am.
Yeah. Thank you so much.
Thank you
Thank
very
you,
much.
Mr.
Yeah, thank you.